Welcome back. We need to continue talking about our families of the periodic table notes. So hopefully you've got this paper, hopefully you've got the top stuff filled out. We need to start filling out this table. We're gonna make it beautiful and colorful. This little table right here, we're gonna do some stuff too, as well as the information on the back, which is really key information about what's special about the families. So let me walk you through how you're gonna work the rest of these notes. So first thing that you'll need, and you can pause now if you need to, you need 9 colored pencils because we got 9 families to talk about. I recommend colored pencils, maybe crayons would work. Markers are probably going to be a no-go because they're going to bleed through the page. So 9 colored things and 1 regular writing utensil. If you don't have that right now, pause this video, go get it, and come back. Okay, so take one of your colors, don't care which one. So from here what you're going to see on my videos is a name of the family in the periodic table here. Then I'll click and it will show a certain area of the table highlighted. So for instance, right here, I've got from LI down to FR with a red box around it. Now it's always going to be a red box. I just happen to pick the color red. It doesn't matter which color you use. But what I want you, actually it's not always going to be a red box. I've got red. It doesn't matter what color you use. I want you to color 2 things. Again, I don't care which color you're using, but I want you to color the name of the family that is at the top of the screen, and I want you to color in also that segment of elements. Okay? So I'm going to do that real quick. I'll pause this and then I'll come back and show you what I mean in case you don't understand. Okay, so I've done my first bit of coloring. And you can see I colored the chunk that says alkali metals in that little table up there red, and I matched that same color to this table down here according to the periodic table shown on the screen right now. So since in that box on my screen is LI down to FR, that's the chunk that I colored in on this table right here. Okay? Now, so for every family, you're going to see this same setup. In addition, I'm going to go through and talk about a couple notes that I want you to know, some important things that make that family special. And that's where you're going to turn to the back of your paper. Now, maybe you also want to color code that. So maybe you want to take that same color that you just used and color it around alkali metals again. You don't have to do that. I like color coding stuff when I can. You got the colors, you might as well do it, but if you don't want to do that, you don't have to. What I do want you to do though is fill in those blanks for each family. So let's go ahead and talk about what makes alkali metals special, and then we'll make sure we're all on the same page here. So for one, alkali metals all have 1 valence electron, which does make them behave in a certain way. And actually, that 1 valence electron makes them very reactive. In a couple of weeks, we are going to actually go outside and experiment, or maybe not experiment, but do a demonstration with an alkali metal to show you how reactive it is. It's pretty fun stuff. I'm looking forward to it myself. The other thing you should know is that reactivity is going to increase as you move down the table. So that means that the things at the bottom are going to be the most reactive. So lithium up here at the top is not as reactive as sodium. Sodium is not as reactive as potassium, and so on all the way down to the bottom. And last thing is that these elements are very soft, so soft that you can actually cut them with a knife. They almost feel like plastic. Again, when we look at them outside in a couple weeks, you'll get to see that. So just to make sure we're all on the same page, looking then back at the back side of your note page, you should have filled in those things that I put right there. Everything that I have underlined in the presentation is going to fill in a blank here on your paper. Okay, so I'm going to keep going through the rest of the families. I'm not going to keep filling out my paper, but I might at least demonstrate the next coloring step. All right, so our next family, I do have different colors here. Our next family is alkaline earth metals. I have them in orange. Again, you don't have to use orange, use whatever color you want. But so take a minute to go ahead and color in those appropriate chunks. I'll do one more example to be sure I know what we're doing here. All right, so here's what I got. Again, I colored in the family name up there, colored in the corresponding tiles on the periodic table according to what's in the presentation on my screen. And then I also did go ahead and color code the information on the back. So let's go ahead and fill in those blanks on the back. That's the last time I'm going to show you my paper there, and I'm just going to talk through the rest of the metals here so you can get things filled in. All right. So the alkaline earth metals have 2 valence electrons. Remember, all we got to do is look at that group number up at the top, and since that is group 2, that tells us all of them have 2 valence electrons. Next up, these metals are reactive. They're not as reactive as the alkali metals, but they still do have quite a bit of reactivity. And then also the reactivity for these is going to increase as you move down the table, just like the alkali metals. All right, so those are the things I need you to know about alkaline earth metals. Next up, we've got transition metals. Here's the chunk they've got there. Now, I'm not going to pause. I'm just going to keep rolling. But as you're coloring, be sure you do not color this little chunk down here. On your periodic table that you've got on your notes, there's 2 like empty boxes. Leave those blank. We'll come back to them in a little bit. But just fill in this sort of funny shape here and color code everything like you would. You can pause now if you want to go ahead and do that. All right, let's talk about what's important to know about the transition metals. So these are the metals that we normally think of. We got copper, iron, gold, stuff like that. A lot of these metals in this transition metal family are the ones we normally think of. They have varying numbers of valence electrons. So we talked about how that middle section didn't have those numbers when we were talking about valence electrons before. It's all over the place. I'm never going to ask you how many valence electrons does chromium have, because you would need to like search to find that out. I would need to search to find that out. So don't worry about that. Just know that they have varying numbers of valence electrons. And finally, these are less reactive than the alkali and alkaline earth metals. They are still reactive, but not quite as reactive. Next up, we've got our rare earth metals. So this is that chunk down below. Now you'll notice that not only do I have this bottom section down here filled in, but also this little chunk right here, because again, that's where they sort of fit into the table. Let me illustrate briefly why we do that. So if we go to ptable.com, if you click up here on this button that says wide, watch what happens. There we go. See how the table sort of fills in. So now we've got this group that's normally below the periodic table filled in, and it makes it really long and short, right? But that doesn't fit very well onto a piece of paper. And so that's why usually when we see the periodic table printed out, we just kind of move this chunk to the bottom. So watch again what happens as I undo the wide setting. Here we go. So it just takes those elements from that one segment and it moves them down below the table, just so that it's literally just so it more easily fits onto a piece of paper and it's easier to view. That's really the main reason why we do that. So anyways, go ahead and color that in, color code things as you need to. Pause the video here as you do that. Couple things I need you to know about the rare earth metals is that this is a special section of the transition metal family. So again, they do sort of fit into that little spot, but they aren't transition metals, they are rare earth metals. And then also, I already said this, but it is situated below the rest of the table, mostly to save space. Okay? The last metal family we've got is just, we call them other metals. So be careful as you're coloring this. Make sure you're looking very closely at the element symbols here, making sure you're only coloring those ones, because I know this is a funny shaped group here. So be careful as you're coloring. Really, these are just metals that don't fit into any of the other special metal groups. All right. Now, next up, I want to talk about this side over here on your notes. So hopefully you've got all this stuff over here filled in. We need to talk about this chunk right here, the 4 metallic properties. All metals. So these other metal families, in addition to the rare earth, in addition to the transition and the alkali and the alkaline earth, all metals have these 4 metallic properties. The first one is that they have luster, which just means that they're shiny. Any shiny metal that you see has luster, whether it's shiny jewelry, whether it's chrome, whether it's the shiny top to my coffee cup, whatever it is, if it's shiny, it has luster. Next, we've got malleability. So if you've ever, I don't know, had like a nail that you were trying to hammer in, but it sort of just kind of flattens out and gets squished weird, that's malleability, okay? I often demonstrate it too with silly putty. Silly putty is actually malleable. We can kind of squish it and flatten it into a thin sheet versus, you know, if you had something like glass, you can't do this to glass. It would just shatter, okay? Wood, you can't squish wood into a thin sheet like that. You can cut wood into a thin sheet, but you can't squish it and flatten it out like that. So metals have that special property of being able to be squished and flattened. Similarly, ductility means we can pull it into thin wires. Again, silly putty is the same. We can pull silly putty into a thin strand. Metal is the same way. If we get metal to the right temperature, we can pull it out and make thin wires and stuff, which is obviously really important for our modern life. And finally, I'm going to move my face over here. Finally, metals have the property of conductivity. They can transfer heat and electricity very well. So that's why we use metals for things like pots and pans and for wires and for things like that. So that's conductivity. So that fills out the entirety of your metals section. The next video is going to talk about the metalloids and nonmetals, but there's everything you need to know for my class about metals.